Hello, I'm Jackson Lee, and this is Physics 2211, Lab 3 for Georgia Tech. The purpose of this lab is to use computational models to, in part 1, find the mass of a black hole using a computation model with a simulated interaction with a star of known mass. And for part 2, we will also use a computational model. However, in this part, we will be finding the initial velocity needed for a spaceship to enter and escape the system unharmed by the planet or the black hole in said system. So there will be two major fundamental principles in this lab, one being the momentum principle, which states that F net is equal to dp dt, which can be broken into F net equals F net parallel plus F net perpendicular for circular motion. And then we also have that dp dt is equal to the magnitude of dp dt times the p hat, so the unit vector, plus the magnitude of p times dp dt. And our second fundamental equation will be the gravitational force, which states that force of gravity is equal to g m1 m2 divided by r squared times r hat, which we can rearrange to say that the m2 is equal to magnitude of dp dt times the magnitude of r squared over g m1, with g being the gravitational constant of 6.7 e to the negative 11. So for part 1 of the lab, first, for the code, you have to enter your own email to get a random number, random seed. And then down in the code, we have delta t as 1 day in seconds. And then for the calculation loop, we have the initial and final velocities here. And then we also have the initial momentum and final momentum, which is equal to mass times velocity. So as you can see, that's mass and velocity. And then we have the delta b and delta p, so the change in velocity and momentum down here. And then it also calculates the dp dt, which is delta p over delta t. And then we have the net force is equal to dp dt, as we saw in the previous equation. Sorry about that. As we saw in the previous slide, F net is equal to dp dt. Then it calculates the parallel change in p and the parallel force. Then it uses this equation to find the perpendicular force. And finally, we get to the mass of the black hole. So through all that, we found that magnitude of the net force was this number, the magnitude of the parallel force was this, the magnitude of the perpendicular force was this, and then finally the mass of the black hole was 7.66 times 10 to the 33rd. Then in part 2, we first entered the mass that we previously calculated for the black hole, and then we see these are the given constraints. And then for the planet speed and velocity, we have this code, and then the speed is calculated through trial and error that we need. So then in this, you have the gravitational on the planet by the black hole, then you have the gravitational force on the planet by the ship, then you have the gravitational force on the ship by the black hole, and the ship by the planet. So we have all four gravitational forces. We use Newton's second law over here to get our results of the planet's orbital speed being this number, the planet's orbital period being this, and we find that the ship ends up 9.89082 times e to the 10th away from the event horizon of the black hole with the speed that we found. Now, so the what if questions. So the net force and components, the question is, how does net force and its components differ from the change of momentum? So the net force, perpendicular, and parallel are the force enacted on the object versus the change of momentum is the reaction of that force. So they will be in the same direction, but they won't be the same magnitude, and they won't have the same, because the force is impacting the object through the change of momentum, is not impacting it through the force alone. The force causes a change of momentum, which we see as a physical impact on the object. And then the second what if question was, what if we wanted the ship to enter a stable orbit around the black hole instead of simply escaping the system? So to do this, you would simply have to change the delta t to 3 hours and use trial and error to get the new speed instead of the original speed that we calculated so that it could escape. And then, as you can see, it has entered a stable orbit around the black hole. Thank you very much. My name is Jackson Lee. This was Physics Lab 3.